Alrighty, today we're going to learn how to solve systems of equations by graphing. The good news is you already have every single skill you need to do these problems. A system of equations is a collection of two or more equations with the same set of variables. In our class, we're just going to be looking at sets of two equations with two variables. Up to this point, we've been solving equations that have one variable. And so it was one equation with one variable. Now we're going to be talking about two equations with two variables. It's possible to solve three equations with three different variables. So basically, the way we do it is we're going to graph the two equations, and then the place where they meet is the solution. Or like we'll say where they intersect. So the solution to a system of equations is a point, an ordered pair. So let's just start by trying one. For number one, if you recall, slope-intercept form looks like this. So that first equation is already in slope-intercept form, and the y-intercept is -2. So one of the points on my graph is the point 0, -2. And then the slope is 1, or like 1 over 1. So I'll go up 1 over 1, up 1 over 1, and here is my line. I thought it was going to make a straight line for me. Let's see. I've got my dog doing her usual heavy breathing right next to me. She doesn't understand that I'm doing something else. And then let's change colors for that second line. This equation is not in slope-intercept form, so let me do that over here on the side for anybody who forgot. It's x plus 3y equals 6. We want to get y by itself, so I'll subtract x from both sides. And I'm putting the x before the 6. Oh, I put a b. It looked like a b. Can't read my own writing. Because I'm trying to get it closer and closer to the y-intercept form. Now I still don't have y by itself, so I will divide both sides by 3. Here they go. So on the left, I have 1y, and then I have negative x over 3, but I'm going to write it like this, -1/3 x, because I know that that coefficient of x is going to be my slope, and that'll make it easier to graph. And then I just have 6 divided by 3, which is 2. So now that equation is in slope-intercept form. So that one has a y-intercept of 2 and a slope of -1/3, which means I'm going down 1 over 3. Oh, I already found the spot where the point where they're going to meet. Down 1 over 3, so over here somewhere. I can also go up 1 and to the left 3, because I could make the 3 negative instead of the 1. And it all falls on the same line. So I just solved this system of equations by graphing because I found the point where they intersect. So the answer is the point where they intersect, which is the point 1, 2, 3, 1. So the answer is an ordered pair. Let's try the next one. I have this equation already in slope-intercept form. It's like y equals 3x plus 0, right? Because nothing's on the end there. So my y-intercept is 0. My slope is 3, which is really like 3 over 1. So I'm going to go up 3 over 1. It's also the same as -3 over -1. Those all fall on the same line. Just remember what we learned, that if it has a positive slope, then from left to right, it is an uphill line. I don't think I needed to thicken that up. Let's leave it like that. Okay, let's get a different color here, and we'll go to the next equation. The y-intercept is -1. The slope is 2, so I'm going up 2 over 1, up 2 over 1, down 2 over 1. Here we go. There's the place where it meets. I'm going to try to make that a straighter line by holding my Apple pencil down. There we go. All right, so the place where these two lines met is right here. So the answer to this system of equations is the point -1, -3. All right, let's try these last two. This first equation is like having a +0 on the end, so the y-intercept is 0. The slope is 3/4, so I'm going to go up 3 over 4. Oops, down 3 over 4, and we've got this. Oh, goodness. Well, that's not as bad as I thought it was going to be. Can I grab it? I don't know how to grab it. Let me try one more time. There we go. That'll be better. And let's change colors for that second line. This one is not in slope-intercept form. So right now I have -4y equals -3x. I want y by itself, so I'll be dividing both sides by -4. And I'll have y equals 3/4 x. So if I have a negative divided by a negative, that's the same thing as positive. So my y-intercept for this one is also 0. So we already found the spot, didn't we? Then we'll go up 3 over 4. Uh-oh, what's happening? Down 3 over 4. So it's actually the same line. And if you look at this equation that I got when I solved for y, it is the same as this equation. So it's the exact same line. When that happens, your answer is all solutions, or you could say infinitely many. That means all the points are on both graphs. And lastly, we've got two equations that are in slope-intercept form already. The first one has a y-intercept of 1 and a slope of -1, which is the same as like -1 over 1. So I'll go down 1 over 1, down 1 over 1, etc. Let's put my... Oh, that ended up being pretty good. And then we'll change colors for the other one. It has a y-intercept of -3, 1, 2, 3. And it has a slope also of -1. So it's going to be like this. So when I graph it, you can see that these are parallel lines. They are never going to meet, so it has no solution. So parallel lines have no solution. One thing to know about parallel lines, which we mentioned briefly way back when, is that parallel lines have the same slope. So see how they both had a slope of -1? I'm going to write that down here just so we can remember it. Parallel lines have the same slope. And parallel lines will never cross, so they do not have a solution to that system of equations. Thanks for watching.